All right, number 7. How much heat in kilojoules right away is needed to convert this much ice at -15 to steam at 138? It gives you the specific heats. All right. So what is going on here? Overall heat. All right. We have ice that's below the melting point. So we got a warm ice. Then we have to melt. Then we have to warm water, the liquid. Then we got to boil or vaporize. Then we got to warm steam. Right? Because we know that at 0 degrees, right, is the melting point, and 100 degrees is the boiling point. And we're starting with ice down here, and we're going to steam up here, if that makes sense to you guys. So we're going all the way past that. So we have 2 phase changes in there. Now, it gives us specific heats of ice and steam, but it doesn't give you delta H F, and it doesn't give you delta H V. So we need to look those up. And so if I look up delta H V, it's 6.01 kilojoules per mole in our book. And delta H F, I have 40.79. Now, make sure you are using the right resources for the book. And just a little knock on McGraw-Hill here. Sometimes their homework platform and their textbook and whatnot can have different constants. So make sure you're using the constants there. Don't just Google constants. If you Google constants, because sometimes there's variability where they're getting it, or sometimes they're making them different on purpose, you could have the wrong answer because of that. All right, so heat. Q equals warming the ice, mass C delta T. Well, now, but this is the mass. The mass is going to be the same throughout. This is of ice, and that's delta T of ice. Melting, delta HV, or delta HF, excuse me, delta HF times the mass. Plus warming the water, mass C delta T, but now it's liquid water. And of course, specific heat of water is 4.184 joules per gram degree Celsius. Vaporizing, delta HV times the mass. But now we have steam. All right, so I got my variables. I think we can plug in numbers now. Q, overall heat. The mass. Now, the mass is the same for everybody, right? 218 grams of ice. So we got 218 grams. Or, sorry, that's not right. So how about this? 212.8. 212.8 grams. All right. Our specific heat of ice was, or is, ice is 2.03 joules per gram degrees Celsius. And what's the delta change? It goes from -15 here to 0. So it's 15.0 degrees. All right, that's the change. All right, plus. Now for this, I have 6.01. I'm in kilojoules, so I'm going to make it times 10 to the third joules per mole, multiplied by 212.8 grams. I'm going to have to also multiply that by 1 mole of H2O is 18.02 grams of H2O. Right? Because I got to get my units to work out. The mass is still 212.8. But now we're in water. 4.184 joules per gram degrees Celsius. And it goes from 0 to 100. So 100 degrees. Continuing on, delta HV, 40.79. Let's make that times 10 to the third joules per mole. And then we still have the 212.8 grams. And we're going to have to go with this again. 1 mole of H2O is 18.02 grams of H2O. All right, so we have that again. And then the last term, we still have our 212.8 grams of H2O. And we're steam now. The steam specific heat is 1.99 joules per gram degrees Celsius. And we're going to 38 degrees Celsius. So 38 degrees. Excellent. So overall, how much heat? You just add up every term. And I think if we add up every term, what do we get? All right. Well, 212.88 times 2.03 times 15. So for the first term, I'm going to get 6479.76 joules. The second term, I get 70972.7. Third term, I get 89035.5 joules. Fourth term, times divided by 18.2. I get up here in red 483,818.9 joules, and 212.8 times 1.99 times 38. I have 16091.9 joules. All right, so let's add all those up. I get a lot. So we get, if I did this right, I get 666,398.8 joules, which makes it 600 and, I guess I got three sig figs, 666 kilojoules. That's what I got. Hopefully that's right.